Welcome to part 2 of crossing installations through the junction. Before we get started on placing these crossing gates on the layout, it's good to understand what the prototype does. I've printed out here some excerpts from the U.S. Department of Transportation, and it's pretty much the same thing in Canada. Here's the Canadian sheets. And they basically say the same thing, that you need about 12 feet minimum from the center line of track to the edge of the gate when it's down. But once you've run a line 12 feet from the center line of the track parallel to the track, you need to measure halfway across the road and find out where those two lines intersect. Once we have located the point in the middle of the road that's 12 feet away from the center line of track, we've determined where the end of the gates is located when it's down. In order to figure out where to actually install the base of the gate, we need to run a line perpendicular to the center line of the road, out to the edge of the road, and that tells us where the gate goes. Here we are. So, end of the gate when it's down, we mark the point on the layout where the base gets installed. Now, in my case, with the road being a little bit higher than the base of the layout surrounding it, I had to build up a support block, which will eventually be painted in like a ballast crib surrounding the footing. We also need to drill a second hole much thicker, almost 1/8 of an inch thick, because the wires that come with these crossing gates, these are the NJ gates. They might be different for other manufacturers, but these come with the resistors already wired in. So in order to fit these through the hole needs to be big enough to slide at least one down at a time. There you go. Now, there's one more hole that has to be drilled. That's the hole you see here. And that's the hole for the actuating wire, which ultimately gets connected to your tortoise switch machine. Now, what I noticed about the NJ crossing gates is that if you drill a hole straight down along the actuating rod, you will never get the gate to line up perfectly vertical. If you pull down, no matter how hard you pull, it's never going to line up. You actually have to pull slightly at an angle like that so that the gate lines up. It's about a 30-degree angle, so when you drill your hole here, you actually have to drill it like that. The difficulty that arises with that is that the actuating rod is not quite long enough if you're drilling through a 3/4 inch plywood or something similar, because when you come through the base of the layout at an angle, you only have about that much sticking out below, and you need to do something to extend that wire before it can be connected to the tortoise switch machines. What I've chosen to do is use the Circuitron remote signal activators. You see the part number there, 800, 8100. And if you look down the instructions, there's a nice picture showing you the way it works. The tortoise switch machine is connected to a base plate that's connected to an activating wire that can be placed anywhere, and can also actually activate more than one turnout or semaphore. In this case, the picture is showing a semaphore signal. But you see where the actuating wire is going straight up and down. That works fine for a semaphore, but as I mentioned, for the crossing gate, the wire has to be at a bit of an angle. So I'm going to use this system to try and connect the crossing gates. I should mention that both parts of this kit come as parts that need to be assembled. It's very simple to put together, but it is a kit that you need to assemble before you install it under the layout. Because we have two gates, and because the system is designed to handle more than one gate, I've also purchased this extra cable and actuator. Here you see the parts, what it looks like before it's put together. That's the finished part once it's assembled. Very few parts to it, so it's very easy to do. Part number 800-8101. So with the main kit that comes with the base plate and one activating crank, plus one other extra cable and actuator, you have all the parts you need to control two crossing gates with one tortoise switch machine. There you see the tortoise connected to the base plate. Behind, here's the moving parts. This will be connected to the motor, and as it turns, it moves this piece back and forth, and there'll be the wire connected here as it was shown in the diagram. Now, getting back to the problem we mentioned earlier about the actuating rod not being long enough. If we consider this space here, the thickness of the plywood plus the thickness of the base that we've added on top of the plywood, you can see there isn't enough length in the actuating rod when it's at an angle here to reach the crank on this part here. On the back side of this part, you can see there's a number of holes pre-drilled. Depending on the amount of throw you need, you choose a different hole. So what I'm going to do, I took apart one of the gate control rods to see how easy this was. This is just a simple soft brass rod. It comes off fairly easily. And what I'm going to do is take a piece of stock brass rod. This is 020 or 0.5 millimeter brass stock, and simply cut a piece that's long enough to run from the gate arm all the way down through the layout to reach the actuator here. Paint it silver and it should be good to go. One of the risks in trying to install crossing gates after you've installed scenery is that you're going to run out of space very quickly. If you're under a tree or near a building that's been glued in. Fortunately, I have this moto tool attachment that allows you to drill 90 degrees to the actual tool. So when you're in a tight spot, this works quite well in drilling underneath the tree. Before you can connect the actuator rod to the actuator below, you need to set the gate arm to its halfway position. And since the two extreme positions are vertical and horizontal, it's simply a matter of finding the position that's 45 degrees. Using a simple set square, we can do that with one hand holding the set square here, and the other hand underneath the layout with a black marker. You mark the edge of the actuator rod where it touches the bell crank to mark where you bend the wire before putting it through the bell crank. Here we have an illustration of what the setup looks like once it's under the layout. Here we see the gate arm at 45 degrees, the actuator rod passing through the layout to the bell crank here, and it needs to be connected to this hole here. So I've marked with black marker one side and the other side, so I know that halfway in the middle I have to bend the wire to fit into this hole. The actuator bell crank is attached to the underside of the layout with little screws that slide in like that. and you screw them in upside down. That's very difficult when you're working in confined spaces on an existing layout. Fortunately, I'm using a Robertson screwdriver with a square head that fits into these tiny half-inch screws perfectly, and it sort of locks in place. So you can, here you go, almost any angle. It doesn't fall out. It's not magnetic, but because of the shape of the screwdriver you can practically hold it at any angle, and especially when you're doing it upside down it's really handy. And it makes it much easier to screw in a screw when you're working almost in the dark, upside down. Very handy screwdriver head. Well, here's a shot of the actuator installed for the far crossing gate. Not an easy installation. I'm going to pan back here so you can see how far back this was from the opening of the layout. Definitely not an easy installation. Each actuator comes with a Teflon tube and a stainless steel wire. The stainless steel wire has to be threaded into this Teflon tube, as you see here done on the first one. The stainless steel wire is clamped down on each actuator and at the tortoise. When you're clamping them down, you have to make sure the tortoise is in its middle position, in the middle of the throw, and the actuator is horizontal. The instructions that come with the Circuitron parts give you a recommended hole to use in both the bell crank here and in the tortoise arm here. You see there's several holes. They're numbered 1, 2, 3, 4, and 5. And depending on which hole you mount the screw in, it affects the amount of movement possible in the larger arm. The recommendation for the NJ International gate arms, according to the instructions, is to use the third hole on the major crank and the second hole, you see here it's listed, the second hole on the bell crank. I found though, because in my application we have the actuator arm at a 30 degree angle, it creates a much longer throw. So I measured the throw actually by marking the movement of the crank on the underside of the layout, and based on my measurements, my guess was that I should use the fourth large hole on the bell crank, which is where you see the screw, and the second hole on the bell crank. We see how the tortoise switch machine mounts to the base plate, and on the underside you can see it's just a simple screw that connects to the major crank, and turning the crank, and I'll do it slowly by hand, you can see the movement of the wires. And you see that it's pulling the wires out or pushing the wires in, just like that. And now we're going to do a manual test of the connection by slowly moving the tortoise switch machine. And that's the fully extended. Now in the other direction. Perfect. Now before anybody says, gee, that looks really easy, you need to understand that because the actuator rod is bent, you can't insert it down from the layout into the bell crank. You have to insert it into the bell crank and mount this to the underside of the layout by pushing this through the hole that you've drilled. not a very easy thing to do. Okay, before we try and mount the second gate arm, it's important to remember that the gate arms have LEDs on them, therefore they have wires connected to them. The NJ International wires are only about 6 inches long, so I have extended those wires with about 2 feet of extra wire, and they're soldered together nicely. Here you'll see that these are the resistors that came with the kit. Important to do this now. If your setup is anything like mine, with at least one of the gate arms far from the edge of the layout, it would be next to impossible to try and solder wire extensions underneath the layout, or in my case between the top level and the staging yard, from a distance of 18 inches away from the front of the layout. So I've got a fair length of wire that I will thread through as I try and mount the gate arm on the throw rod, which you can see now is sticking up out of the layout, because we screwed in the bell crank upside down and threaded this as we were doing that. So now the test will be, is it the right length? Does it match the other gate arm that's here? And here's a close-up view of the connection between the actuator rod that rises up from beneath the layout and connects to the gate arm via this hole on one side of the gate arm. No matter how hard you try to get the gate arm to sit perfectly vertical or perfectly horizontal at the end of its throw, at the end of the tortoise switch machine throw, it will likely not be exactly right. I spent a fair bit of time fiddling with the connections underneath the layout before realizing that the best thing to do was to try and adjust it through some other means at the very end. So once I tightened everything up with the actuator wires and the tortoise switch machine beneath the layout, I came back up to the top and added a little shim, it's a little cardboard shim you can see here, to the underside of the footing of the gate arm, and the effect that had was to pull on the actuator rod, which made the gate arm more vertical. So don't be too concerned if you don't get it exactly right. You will have to do some fiddling about with the various points within the system to get the gate arms to act exactly as you want them in the end. The last step of the installation is the wiring. Each gate has 3 wires connected to it. 2 wires in white connect to each of the LEDs, and the blue wire is the power wire. Now you'll recall I extended these wires. You see there's the resistors. I extended those wires so that I can connect them to the wires coming out of the other gate. So there's a little terminal strip where you can see the resistors from the second gate and the wires coming in from the first gate on this side, and the other set of wires going down to the circuit boards. The last thing that has to be wired in is the tortoise switch machine, which controls both gate arms through the steel cables. And you can see back of the tortoise wires to position 1 and position 8. There we go, that's a better view. Position 1 and position 8, and those 2 wires come down to the gate controller circuit board. And here we are back under the layout, and taking a look at the wires associated with the gate arm and tortoise switch machine. They all get connected in to the master control circuit board. You see here labeled GM. Those 2 terminals are for the switch machine. R0 and L0 are for the LEDs, and this orange wire here connects to DC. All 5 of these cables conveniently fit in some leftover Bell bundle cable. It's a 6-wire cable. And now the moment we've all been waiting for, the grand test. And there you have it. I hope you've enjoyed following along as much as I've enjoyed trying to piece it all together. Thanks very much for watching.